The capabilities of AI are advancing rapidly, and with the Microsoft Quantum Development Kit and its tight integration with VS Code and GitHub Copilot, you can leverage those capabilities in your quantum learning, research, and development. In this quick video, I'll give you an overview of just a few of those capabilities. To follow along, you'll want the QDK installed. For more details on that, go to aka.ms/qdk.install. Let's get started. To use GitHub Copilot, you'll need to sign in with a GitHub account. You can go to the Copilot settings to see your plan and the models available. I'll use my test account to demonstrate enabling AI features and signing in with a free tier GitHub account in VS Code. In VS Code, open a chat window, enable AI features, and then sign in with your GitHub account. Once signed in, you can select from the models available in your plan. Here I'll leave the model selection at auto and ask it a simple question about the currently open quantum code. For the main demo, I'll switch to my personal GitHub account where I have more models available, and here you can see the list at the time of recording. I'm going to try to avoid writing any quantum code in this demo, so I'll start by dropping in a screen clipping of a quantum circuit and asking Copilot what it is, and can it write the QASM code to implement it. It's done a pretty good job recognizing teleportation and implementing it, and it runs correctly. One area where AI shines is in porting code, so I'll ask it to rewrite this QASM to QSharp so I can take advantage of the QSharp unit testing features. Looks like it successfully ported that code from QASM to QSharp. Let's ask it to refactor this code to make it more testable and ask it to write some unit tests to verify teleporting various quantum states. It's added the necessary imports, written the tests, and they all pass. It's also given me a nice summary of the tests it wrote. It's written this arbitrary state teleport test, and I'm going to ask it to explain to me how this works. It's done a pretty good job outlining its use of adjoint operations to undo the prepared state on the target qubit and check for the zero state. To check its quantum understanding, let's ask it to remove any mid-circuit measurement and implement the algorithm with quantum-controlled gates instead of classical control flow, and then verify the tests still pass. And it's done a good job of making those changes, and the tests are still passing. Okay, well, let's introduce a bug. Maybe something with a typo or a cut and paste error. We can now see the tests are failing. Starting from a clean Copilot session, let's ask it to find and fix the bug and ensure the tests pass. And it's correctly identified the issue, made the change, and the tests are all passing again. Let's clear out this code and work with something a bit more complex, such as the built-in Grover's algorithm sample available from the editor completion list. We can ask Copilot to explain parts of this algorithm, such as how does the reflect about uniform operation work, and we can see it's combined its understanding of the code with its quantum knowledge to give a comprehensive answer. We can also ask it to explain aspects of the language we may not understand, such as what does the within apply pattern do in QSharp. And here you can see you can use Copilot to help you learn quantum programming languages. We can ask it to give us resource estimates for running this on an error-corrected system, and it will use the integrated resource estimation features to come back with a comprehensive analysis. If I'm happy with this code, I can ask it to check the status of the hosted simulators available in my Azure Quantum Workspace, and then to submit the job to the simulator I'd like to use. As there's a little queue time right now, I'll ask it to fetch the results of the last completed job on that workspace, and it'll fetch the results from the service and display them in a histogram for me in VS Code. In a few minutes, I had Copilot write some quantum code starting from the simple image of a circuit, refactor it, test it, explain some of the algorithm to me, explain some other quantum concepts, fix a bug, run a simulation, connect to the service, submit the job, and fetch the results, all without me writing a single line of code. I highly encourage you to give it a try and explore some of the capabilities for yourself. Happy quantum coding!